everyone, Miss Sanders coming to you here, giving you a review of standard algorithm. So we are going to tackle basically the hardest type problem that could be on the test on Monday, which is a 3-digit times a 2-digit. So if I had 452 times 18, first of all, I'm going to rewrite it. I want this 18 to line up with my place values on my first number. All right. So I'm going to use different colors. Let me see if I can move this. I'm going to use different colors because it helps me keep track. So you are very welcome to do that yourself. Okay. First of all, I'm going to ignore this one. I'm just going to deal with the 8. And I'm going to do 8 times 2, which is 16. But this is my tens place. And I can't fit a 1 and a 6 in my ones place. One number at a time. So I'm going to write my 6 and I'm going to carry my 10. And I'm going to write a plus 1. I'm going to write a plus 1 because sometimes I forget if I'm supposed to add or multiply that. So if I write the plus 1, I know add. Okay, next we're going to do 8 times 5, which is 40, plus 1. Okay, so I've got a 41. One place value at a time. So I'm going to put my 1 here and I'm going to carry my 4. Last but not least with the 8, we're going to do 8 times 4. Now, we know that this is 8 times 50 and 8 times 400. But the beauty of the standard algorithm is that you kind of get to forget that and just treat it like a 4. Because when we answer, this is going to be 32 plus 4 is 36. If I just write 36, because there's no other number to carry, it ends up in the thousands place where it should be. So the beauty is you don't have to think about it in the true place value sense anymore when you do this. You're kind of past that at this point. So I've already used the 4 and the 1. So I'm going to get rid of those. And I've used the 8. Don't want to use the 8 anymore. I'm moving on to 10. Now, remember what I just said about not having to think about it like a 10? We get to think about it like a 1. That is just because we're going to put a place value or placeholder 0 here. That 0 is like the times 10 shift. So we've multiplied this by 10. Here's our 0 that we added, that y'all like to say we just add zeros. And now we get to treat this like a 1. So 1 times 2, 1 times 5, or 50. 1 times 4, or 400, is 4. So I'm going to go back, and I'm just going to add it up. Starting ones place, going over greater place values as I add. So my answer is going to be 8,136. Now, if you do standard algorithm, you're going to get done more quickly than people who do area model or partial products. So I expect you to check your answer. And the best way to do that is to get a new sheet of paper. Don't do it right beside this. Get a new sheet of paper and do it again. If you get the same answer both times, chances are you're right. If not, we need to go back and figure out like where the mistake was made. And most likely it was made because you forgot to add the 0 right here as the placeholder. So anyway, you guys have been rocking it. You're going to do great. Email me if you have any questions, and I hope you have a fantastic weekend. Bye.